about the risk they say is posed by some of these Chinese open source models. They have been lobbying for tighter restrictions, and their argument has been about safety and geopolitics. So they say, or the argument there would be, once the most powerful models are released openly, they are impossible to control, they can be exploited.
Our adversaries don't follow regulation. So while the Mythos model's been put on hold, there's other open source models out there that have proven to be nearly as effective at finding these vulnerabilities and exploiting these vulnerabilities. They don't have the guardrails, for example, that Mythos puts in place for using it maliciously.
OpenAI and Anthropic have closed models. They're in control. That means that when an OpenAI model went rogue and hacked into AI library Hugging Face recently, it had to use an open-weight Chinese model to defend itself.
Disadvantaged because open models are the way smaller companies compete. Most startups cannot afford to train a frontier model from scratch, and they can't always afford to run their products on the most expensive closed models.
Everyone is asking the same question: when will open source AI finally beat GPT, Claude, or Gemini? But I think that is the wrong question. Open models do not need to become number one, they only need to become good enough that companies stop paying a premium for the best closed model on every single task. And according to the data, that moment is getting much closer. Stanford's 2025 AI Index reported that the performance gap between leading closed and open-weight models had fallen from 8% to just 1.7%. But the latest report adds an important reality check. By March 2026, the closed model lead had reopened to around 3.3%. So no, OpenAI has not won, but closed AI is no longer competing against weak alternatives either. And this matters for more than leaderboard arguments. It can change which tools developers should learn and which AI startups have a real moat, and whether companies should build and closed APIs, open models, or both. First, open source is often the wrong term. Before comparing the two sides, we need to fix one very common mistake. Most models people casually call open source are more accurately described as open weight. A closed model gives you access through an interface or API, but you do not receive the underlying model weights. An open weight model lets you download those weights and, depending on the license, run or modify the model yourself. But weights are not the same thing as full source code. Think of it like receiving a compiled application without receiving everything needed to reproduce how that application was originally built. The open source initiative says genuinely open source AI should give people the freedom to use, study, modify, and share the system. Its definition also expects access to the model parameters, relevant source code, and detailed information about the training data and training process. That distinction is not just word policing, it affects reproducibility, it affects licensing, it affects what developers can audit, and it affects whether a company can honestly claim that another company's model is part of its own independent technology stack. For the rest of the video, I'll mainly use the term open weight, even though open source AI is still the phrase most people search for. Now let's look at the actual model race. Stanford's detailed timeline shows something very different from the simple story that open models are steadily and permanently catching closed models. In May 2023, the leading closed model was ahead of the leading open weight model by around 15.2% on the Arena leaderboard. By August 2024, that difference had collapsed to approximately 0.5%. Then closed models moved ahead again. By March 2026, the difference was approximately 3.4% on the detailed chart, rounded to 3.3% in Stanford summary. 6 of the top 10 Arena models were closed. This tells us three things. First, open models really have improved dramatically. Second, catching up is not the same as permanently taking the lead. And third, the gap moves in cycles. A closed lab releases a new frontier model, it jumps ahead. Open models developers study the new techniques, improve training, and release stronger alternatives and compare the gap again. then another closed frontier release changes the race. So this is not a straight line, it looks more like a staircase. Epoch AI looked at this competition in a different way. Instead of asking how many leaderboard points separate open and closed models, it asked how much time open weight models take to reach previous frontier capability. Its May 2026 analysis estimated that the best open weight models had been trailing state-of-the-art closed models by an average of roughly 4 months since the beginning of 2026. Not 4 years, not even 1 year, around 4 months. But the researchers also added two important warnings. Open models may look better on public benchmark than on private benchmarks because developers can optimize more aggressively for public tests, and some closed companies may not release enough information about their most advanced internal systems for them to be included properly. So the 4-month number is not a law of nature, but it supports the broader conclusions. The best open models are no longer living in a completely different capability era. They are often following close behind the frontier. And this is where we need a reality check about benchmarks themselves. Stanford's 2026 report highlighted growing reliability problems in popular evaluation. A review found invalid question rates ranging from 2% on one benchmark to as high as 42% on another. It also cited research suggesting that arena rankings may partly reflect optimization for the platform rather than general capability. So when somebody says Model A is only 3% points behind Model B, that does not automatically mean the two models are interchangeable in production. One model may be better at coding, another model may be better at tool use. One may follow instructions more consistently, another may be cheaper but generate far more tokens while reasoning, and a model that performs well on a clean benchmark can still fail badly inside a messy company workflow. A recent government evaluation gives us a good example. In 2026, NIST Center of AI Standards and Innovation evaluated DeepSeek V4 Pro. Based on DeepSeek's own reported results, the model appeared to be roughly 2 months behind leading systems. But on Center for AI Standards and Innovation's evaluation suite, which included non-public tests, it appeared closer to 8 months behind the frontier. That does not prove that public benchmarks are useless. It proves that independent evaluation matters, and it proves that no serious engineering team should choose a model using one leaderboard screenshot. But open models are genuinely capable. At the same time, we should not swing to the opposite extreme and pretend open models are only cheap toys. In July 2026, Center for AI Standards and Innovation said GLM 5.2 was probably the most capable open weight model available when it was released. Its overall capability was assessed as similar to GPT 5.2, a closed model released several months earlier. Its hyper capability was assessed as similar to Anthropic's Opera 4.6. This is not frontier parity across everything, but it is serious capability, and this supports what I think is the central point of the entire video. Open models do not need to beat the newest closed model on every benchmark. For many companies, matching the capability of a strong closed model from 4 or 6 months ago may already be enough. A customer support classifier does not need to win an international mathematical competition. An internal document search system does not necessarily need the best creative writing models on earth. So why do closed models still dominate the headlines and many production deployments? Because companies do not buy model weights. They buy outcomes. A closed provider can package the model with hosted infrastructure, global capacity, monitoring, tool calling, multi-modal features, safety systems, documentation, support, and a polished user experience. A developer can call an API without first becoming an expert in GPU scheduling, quantization, batching, inference engines, and model serving. That simplicity has enormous value. Closed labs also still have the frontier advantage, and on difficulty tasks, the final few percentage points can matter more than they appear. If an AI agent performs one action, a small reliability gap may be acceptable. A model that is 97% reliable at each independent step would have only about a 54% chance of completing all 20 steps without a failure. That example is simplified, but it shows why a small pre-step difference can create a large end-to-end difference. Closed models therefore remain attractive when a company needs maximum capability, minimal infrastructure work, rapid deployment, or managed enterprise support. Closed AI is not surviving only because of marketing. It still offers real technical and operational advantage. But open models have a different kind of power. They give developers and companies more control over where the model runs, how it is modified, which provider hosts it, and how long a particular model version remains available. They make local, on-premise, private cloud, and edge deployments possible when the model and hardware requirements permit it. They allow teams to customize the models for a narrow domain instead of repeatedly paying a larger general-purpose model to solve every problem, and they produce dependency on a single API provider. This ecosystem is no longer small. Stanford's 2026 AI Index reported 5.6 million open source AI projects on GitHub and said Hugging Face uploads had tripled since 2023. The Linux Foundation review also reported that 63% of companies were using an open model and that 89% were using some form of open source somewhere in their AI stack. So I would treat those figures as directional evidence, not as perfectly neutral measurement. But even with that caveat, they show that open models are not limited to hobby projects, and there is a larger market trend helping them. Stanford reported that the inference cost required to reach roughly GPT 3.5 level performance fell more than 280-fold between November 2022 to October 2024. That was not caused only by open models. Hardware, software optimization, smaller models, and competition all played a role. But it shows how quickly capable AI is becoming cheaper and more accessible. However, there is another myth we need to kill. An open weight model is not automatically a free AI system. The download may be free, the system around it is not. You may need GPUs, you need serving infrastructure, you need scaling, you need observability, you need security reviews, model evaluations, updates, and somebody who answers the phone when the system fails at 2 in the morning. For a small team with unpredictable usage, a closed API may be significantly more practical. For a company with stable, high-volume workloads, strong infrastructure talent, strict data requirements, or a need for the deep customization, self-hosting may become more attractive. Neither answer is universally cheaper. The answer depends on utilization, hardware, latency targets, staffing, and how much operational complexity the company can handle. Open-weight also does not automatically mean private. If you send requests to a third-party host, your data is still being processed by an external provider. And open-weight does not automatically mean safe. Center for AI Standards and Innovation noted that regardless of a model's built-in jailbreak resistance, safeguards can be circumvented when an open-weight model is self-hosted. Finally, open-weight does not automatically mean transparent. A file containing billions of parameters does not tell you exactly what data was used, how many data was filtered, and why the model learned a particular behavior. That is exactly why the open source initiative distinguishes downloadable weights from fully open source AI. This competition creates a major problem for weak AI startups. If a startup's entire advantage is we placed a user interface on top of a powerful closed API, then every improvement in open models reduces that advantage. Every reduction in inference cost reduces it again, and every new model makes it easier for another company to build something similar. The stronger startup modes will be elsewhere: proprietary or legally defensible data distribution, deep integration into an existing workflow, a trusted relationship with customers, domain-specific evaluations, security and compliance, network effects, are an operational system that is difficult to reproduce even when competitors have access to the same underlying models. This is similar to cloud computing. Access to servers was once a major advantage. Now almost every startup can rent infrastructure. The advantage shifted to what the company builds on an infrastructure. AI models are moving in the same direction, although the most advanced models are not yet complete commodities. For developers, the worst strategy is becoming emotionally loyal to one model company. Your durable skill is not knowing the perfect prompt for one provider's current model. The model may be replaced in 6 months, its price may change, its API may change, or a cheaper open alternative may become good enough for your workload. The more valuable skills are model evaluation, system design, data engineering, security, observability, context management, and understanding the trade-offs between quality, latency, and cost. Here is the practical framework I would use. First, test models on your own workload, not only on HumanEval, not only on Arena. Create a small representative evaluation set from the tasks your users actually perform. Second, keep the model layer replaceable. Separate your business workflow from the model interface wherever possible. So has open source AI caught closed AI? Not completely. Closed models still hold the frontier leads, and their managed products remain easier for many companies to deploy, but the old assumption that open models are years behind and irrelevant for serious production work is also wrong. That gap has compressed dramatically. Independent research estimates the lag in months, not years. The real future probably will not completely open or completely closed. It will be hybrid. Closed models at the frontier, open models handling more customized, private, and high volume workloads, and developers building systems that can move between them. But OpenAI increasingly controls the pressure underneath the entire market, and that pressure may matter more than who is temporarily number one.